Okay, I want you to notice that in the previous example, solid iron was being produced at the cathode of that electrolytic cell. All right, and in an electroplating cell, metals are plated at the cathode. All right, so our previous cell could have been electroplating. I'll just show it to you again. So at the cathode, iron ions were being reduced to solid iron, so we could have plated the copper electrode with iron. Examples of electroplating, you'll see chrome-plated car parts. They look shiny and nice. Okay, gold-plated jewelry. Solid gold is really, really heavy and soft. So most jewelry is something like stainless steel that's just plated with gold. And copper-plated coins. So you'll notice newer pennies, before they were discontinued, were actually magnetic. Older pennies were not magnetic. Older pennies were solid copper, but newer pennies were just copper-plated stainless steel. Okay. Next, I get into a short topic, mostly information here, but I'm hoping it's going to make some sense. Okay, we call it cathodic protection, ways of preventing corrosion of metals. There's two common ways to cathodically protect a metal. The first one that you can see there is called impressed current. Okay, and it's just turning the metal you're protecting into the cathode of an electrolytic cell. So you connect a power supply to your metal, and the metal is connected to an anode, often carbon, and the anode is something you don't really care about. Okay, but that external power supply forces electrons to go from the anode to the cathode. Okay, and if your cathode is constantly being bombarded with electrons, it can't oxidize. It can't give away electrons if there's so many kicking around. Okay, so the anode will oxidize, and the metal you're protecting won't. Older pipelines use this as a protection from corrosion. So there would be power supplies located in various locations, just pumping current from an anode to a cathode. All right, the second way is called a sacrificial anode, which sounds cool, and it is. So a sacrificial anode is a stronger Ra, often zinc, that's in contact with the metal you want protected. All right. The zinc, the sacrificial anode, is more easily oxidized, so it's going to give up its electrons to the cathode, which is the metal you want to protect. Again, the cathode doesn't oxidize. It's always gaining electrons. So in this way, you're protecting the metal by connecting it with zinc. Two really easy examples. Your hot water tank is a sacrificial anode, just a core of zinc dropped inside. And as that oxidizes, the zinc wears away, and then eventually your water tank starts to oxidize. And just a pro tip, if you see any rust spots on the outside of your water tank, you can get it replaced. If it's still under warranty, it'll be free. I went through this process a couple years ago. It was really simple. All right, another example are galvanized nails. And those are just zinc-coated nails, nothing fancy. They're dipped in molten zinc, and the zinc hardens around the nail. Then you pound it into whatever you're building, and the zinc will oxidize before the nail itself, which just makes the nail last longer. Okay, I hope you enjoyed this video.